Question number 10. A sector AOB of a circle, center O, has radius r centimeter and angle theta radians. Given that the area of sector is 6 squared centimeters and that the perimeter of the sector is 10 centimeters, show that 3 theta squared minus 13 theta plus 12 is equal to 0. In this part of the question, we are provided with two information. One, area of sector is 6 squared centimeters, and 2, perimeter of the sector is 10 centimeters. So let's write this down. Area of sector is equal to 6 squared centimeters. Area is half r square theta, and we equate it to 6. Therefore, r theta is equal to 12. Let's write this down as equation 1. Moving on to perimeter. Perimeter is equal to 10 centimeters. So, if we observe, the perimeter is radius plus the arc length. Okay, so let's write that down. Perimeter is radius plus arc length. Arc length formula is r theta. Therefore, we have 2r plus r theta is equal to 10. We can remove r common out. 2 plus theta into r is equal to 10. So let's call this 2. Now, we need to show that 3 theta squared minus 13 theta plus 12 is equal to 0. Now, we must be able to observe here that we only have theta. We do not have r. So, we must make r the subject of formula in order to obtain this equation. So let's make r the subject of formula. We can continue from here. So r is equal to 10 divided by 2 plus theta. Okay, once we have made r the subject of formula, we can substitute this value into equation 1. So we made r the subject of formula in equation 2, and now we can substitute it in equation 1. So let's do that. So we have equation 1, r square theta is equal to 12. R can be replaced by 10 divided by 2 plus theta, the whole squared, times theta is equal to 12. This is the same as 10 squared times theta divided by 2 plus theta, the whole squared, is equal to 12. It can be simplified to 100 theta divided by 4 plus 4 theta plus theta squared is equal to 12. Now what we can do here is 100 theta is equal to, we can consider this as a whole bracket that moves to the right hand side. So since on the left hand side it's in the denominator, on the right hand side the bracket will multiply. 4 plus 4 theta plus theta squared, 100 theta is equal to 48 plus 48 theta plus 12 theta squared. We can move the 100 theta to the right hand side. So we will have 12 theta squared plus 48 theta minus 100 theta plus 48 is equal to 0. Now we have 12 theta squared minus 52 theta plus 48 is equal to 0. Now here we have a quadratic equation. 12 theta squared minus 52 theta plus 48 is equal to 0. But what we require to show is 3 theta squared minus 13 theta plus 12 is equal to 0. So what we observe here is that every term here is multiplied by 4 if we compare it to the terms in the equation that we require. So we have 3 and 3 times 4 is 12. We have negative 13 and negative 13 times 4 is negative 52. And we have 12 and 12 times 4 is 48. So it's clear that if we divide both left hand side and right hand side of the equation by 4, we will get the required equation. So we divide left hand side and right hand side by 4. On the left hand side we are left with 3 theta squared minus 13 theta plus 12, and on the right hand side we have just 0, and this is the required answer. 10b, hence find the possible values of r and theta. Now from part A of the question we have 3 theta squared minus 13 theta plus 12 is equal to 0. So first let's solve this to find the values of theta. Now this is a quadratic equation which can be solved by the product and sum method. So our product here is 12 times 3, which is 36. Our sum is negative 13. We need to find two numbers that multiply to give 36 and add up to give negative 13. So the numbers are minus 9 and minus 4. So let's solve this by splitting the middle term. 3 theta squared minus 9 theta minus 4 theta plus 12 is equal to 0. 3 theta can be removed common out from the first and second term. Theta minus 3 minus 4 is removed common out from the third and the fourth term. So we have 3 theta minus 4 into theta minus 3 is equal to 0. Therefore 3 theta minus 4 is equal to 0, or theta minus 3 is equal to 0. Therefore theta is equal to 4 divided by 3, or theta is equal to 3. So we have got two values of theta here. Now for each value of theta we can find the corresponding value of r. So when theta is 4 divided by 3, we can use the equation r is equal to 10 divided by 2 plus theta, which is from the first part of our question, to substitute. So we have r is equal to 10 divided by 2 plus theta. Theta can be replaced by 4/3. We can solve this by taking LCM. multiply top and bottom by 3. So we have r is equal to 10 upon 10 divided by 3. Therefore r is equal to 10 divided by 10 divided by 3, and r is equal to 3. Okay, so when theta is 4/3, r is equal to 3. Let's find the other value. When theta is 3, r is equal to 10 divided by 2 plus 3. So r is equal to 10 divided by 5. Therefore r is equal to 2. Okay, so when theta is 3, r is equal to 2. Alright, so we have got value of theta, and against it we have got corresponding value of r, and that's the answer.